So I was just thinking that just 1 minute. I think you shared the syllabus of the exam with me, right?
Yes, ma'am.
Okay, just 1 minute. Let me just see that. No, Harsha, I think you have not sent me. Okay, midterm portion you have given me that quadratic equation, arithmetic progression, triangle, and coordinate geometry. Midterm
Yes,
means
ma'am.
half yearly, right?
Yes, ma'am.
So all these chapters we have already done. Hamna, what about your syllabus? I mean, probability is coming or not? Because in some schools it is coming in the half yearly exam.
Ma'am, my half yearly exam is cancelled.
Cancelled, okay. So then I can start probability in the next class. First of all, let's solve the questions. So can you tell me the question number, Harsha?
Ma'am, the extra questions?
Yeah, which I gave you. I think you were not able to solve all of them.
Ma'am, I didn't try all of them. I had many school projects and records to do.
Okay. All right. So then if you sit for the revision, please try to solve because they are questions of R.T. Sharma. Okay. So I just gave you for some practice. So it will be good if you solve them. 12 questions are there. And they were all
Okay.
previously asked in CBSE examination. So that's why I gave you all of them, which I gave, yeah. Uh, okay, then I just want to start a new chapter today, which is called probability. It's a small chapter, so I thought let me finish it first. So can you tell me what you understand by the term probability? You must have studied in class 9th also.
Ma'am, the possibility of something to happen.
You can say measure of possibility, right?
Yes, ma'am.
Yeah. I mean, possibility or chance. So when you measure that chance, that how much is the chance or how much is the possibility, so that measure is actually called probability. Clear? Okay. So for example, you're tossing a coin. So there can be two possibilities. Either you get a head or you get a tail. So you want to find out that how many chance are there, how much chance is there of getting a tail. So this how much is actually probability. Understood?
Yes, ma'am.
Okay. Now there are few terms related to it which we often use. One is called event. Uh, just 1 minute. Let me open the book. Just 1 minute. Yeah, okay. Actually, I was thinking, let me explain with the help of questions, but okay, let me just tell you few terms first of all. Now, what is an event? Event means when something is happening. For example, you are getting a head. Okay, so this is called an event, or you're getting a tail. This is called an event. So event, I can say like getting an outcome is called an event. Understood? Getting an outcome is called an event. so I get a head, it's an event. Like it's an event of getting a head. I get a tail, so it's an event that I get a tail. Clear? Because this term is like very often used in this chapter, right?
Yes, ma'am.
Okay. Now also outcome you understand. For example, I'm throwing a dice. So either I can get 1 dot, I can get 2 dot, or I can get 3 dots, right? I can get like 4 dots like this, or there are 5 dots, or then finally I get a 6 dot. So I get a 1, 2, 3, 4, 5, or 6. So all these are my outcomes. So there are 6 possible outcomes in this case, right?
Yes, ma'am.
6 possible outcomes are there. Okay, now then there's a term which is called favorable outcome. Favorable outcome means like what exactly you want from that event. Like I'm throwing a dice and I want to find out the probability of getting a 4, right? So in this particular, you can say trial, okay? The throwing of a dice is actually a trial. Understood? Tossing a coin is called a trial. So there are two terms. First of all, try to understand. One is called a trial and one is called an event. Now, trial is actually the action of doing something, right? Or you can say action which results in an outcome, which gives you some outcome, right? So this action is called a trial. So example like tossing a coin. This is a trial, right? Or throwing a dice. This is a trial. Understood?
Yes, ma'am.
Okay, throw of a dice or toss of a coin, it's a trial. Now event, as I told you, that getting an outcome is called an event. This is an event, right? For example, like getting a head. So you have tossed a coin and getting a head is an event in itself. So in this particular trial, only 1 time 4 is coming, right? So your favorable outcome is actually 1 in this case. Clear? Because you are trying to find out the probability of getting 4. So on this particular dice, only 1 time 4 is occurring, right? So your favorable outcome is 1, but this trial can result in 6 possible outcome. Either you get a 1, you get a 2, 3, 4, 5, 6. So out of all these 6 possible outcome, your favorable is 1, right? So
Yes, ma'am.
1 by 6 is the probability. So there's a formula of probability which we will use. E is any event. Okay. E means probability of getting an event. So E is number of favorable outcomes and divided by number of all possible outcomes. So this is the formula which we will be using. Right? Okay. Now try to understand one thing. For example, an event is happening, right? For example, you have tossed a coin, right? And your event is getting a head. Understood, Hamna? Right? So you want to find the probability of getting a head. So you write let E be the event. What is the event? Getting a head. So you are finding the probability of E. So there are two ways of writing. Either this, that you first of all give it a name, which is E, and you find P of E. Or you simply write probability of getting head. That's it. This way also you can write it. Okay. So probability of getting head. So what is the formula? Number of favorable outcomes and divided by number of all possible outcomes. Now, possible outcome can be either you get a head or you get a tail. Only these two possible outcomes are there, right? And what you want head, which is like only one time it is there on the coin. So your favorable outcome is 1, total outcomes can be 2. So 1 by 2 is the probability. Okay. So if you find the probability of not getting head, so not getting head means it is same as getting a tail, isn't it? Yes.
Yes, ma'am.
Okay, so it is same as getting a tail. So that means again, we can say it is 1 divided by 2. And if you add these two events like getting ahead and not getting ahead, so it is half plus half, which is actually 1, right? So the maximum probability of an event is 1. The value of probability lies between 1 and 0. It can be equal to 0 also, it can be equal to 1 also. Right? So in a certain trial, if you add all the probabilities, the answer will be 1. It will never be more than 1. So the probability of all the events sum up to 1. So let's take some questions, and with the help of questions, we will keep on understanding, because this chapter, there are, it's better understood with the help of questions. Okay, now there is one thing left, which is important. So there's a term called equally likely. This is important to understand, right? Equally likely, what does it mean? Your events should be equally likely. That means uh, the chance of occurring one event is not affecting the chance of happening another event. Okay. For example, you are tossing a coin, right? uh, you can see in the starting of a match, cricket match or a football match, a coin is tossed. So why we toss a coin? Because it's a very fair, you can say fair event. Why fair event? Because uh, there are no indication on that coin, like you have not make a mark, or for example, we play with some slips or some cards. Sometimes students make a mark on some cards so that they can identify their card, right? So there you can say the chances of getting a certain cards are not equal because there is a bias here. Okay, there's a certain hint, there's a certain indication. But in case of this tossing a coin, it's a fair event. I mean, both the possibilities, that means head and a tail, you don't know what is going to come. It is unpredictable. Understood? I mean, the chance of getting a head will not affect the chance of getting a tail. Is it clear?
Yes, ma'am.
ma'am.
Okay, so such events are called equally likely. So you only have to consider this kind of events only. Let me take one example. It's from NCRT book only. That, for example, you are starting a car, right? Okay. Now there can be two possibilities, that it starts or it does not start. So what do you think? Is this event equally likely?
No, ma'am.
Why no?
Yes,
Because
ma'am.
Okay. Harsha thinks yes. Okay.
more likely to start.
More likely to start. Okay. So Hamna feels that there are more chances that it will start, you know? See, actually, that depends on the condition of the car. If the car is new, right? It's very maintained. It's a running car, so there are greater chances that it's going to start, right? And if it is a old car which was like standing in the garage for many years, and you are starting it, so there are greater chances that it will not start. Fine, Arsha.
Yes, ma'am.
So this event is not equally likely to happen, because there's a dependence on something. There's a dependence on the condition of the car. So we cannot say that starting or not starting have equal chances. But in case of coin, there's no dependency, right? There are equal chances of getting a head or a tail. Similarly, in the case of dice, if the dice is in perfect shape, sometimes there's a dent on the die or there's a hole on the die, so it affects, right? There are certain number which keep coming on most of the time. So such kind of dice is not a perfect dice. So the events will not be equally likely in that case. But if the dice is like perfectly same shape from all the corners, all the sides, then it will give to, you can say, equally likely events. Understood? Okay. So now I think one by one I'll take up question and then we will understand. So with the help of exercise, we will understand the chapter. So is my screen visible?
Yes, ma'am.
Okay. Now first question. Complete the following statement. Probability of an event E plus probability of an event not E. So this I told you, probability of an event plus probability of not E is 1, right?
Yes, ma'am.
Okay. The probability of an event that cannot happen is the event which
0.
0, there is no probability. Such an event is called, so it is called impossible event. The probability of an event that is certain to happen, like you are very sure that this thing is going to happen, that the probability is 1, right?
Yes, ma'am.
Okay, such an event is called sure event. Okay. Fourth, the sum of the probabilities of all the elementary events of an experiment is. For example, dice example I want to take, right? So total number of outcomes are either you get a 1, you get a 2, you get a 3, 4, 5, 6, right? So the total possible outcomes are 6, right? Now
Yes, ma'am.
let me find the probability of getting a 1. So I want 1. So my favorable outcome is 1. Total outcomes are 6. So 1 by 6 is the probability. Similarly, if I want 2, so it will be 1 by 6, right? Because
Yes, ma'am.
2 is occurring one time only. And probability of 3 means again 3 is occurring one time and total 6. Similarly, all the numbers have same 1 by 6 as the probability. Now you can check if you want to add all these probabilities. So this is a simple experiment, and these are the, all the elementary events of this experiment. So you add 1 by 6 plus 1 by 6. So basically you are adding 6 times, right? So the answer is 1. So in the same experiment, if you add all the probability of all the elementary events, it will be 1. The probability of an event is greater than or equal to. So either it is always greater than 0 or equal to 0 and less than or equal to 1. Okay, why? For example, there's a question also. For example, there's a bag, right, which is containing only yellow balls, right? Only yellow balls are there. Okay.
Okay.
Or you can say 4 yellow balls are there in the bag. Now I ask you to find the probability of getting a red ball, right? So how many times my favorable outcome is occurring here?
0 times.
0 times, because there is no red ball, right? And total possible outcomes are 4. That means I am taking out a ball. So what are the 4 possible outcomes? I get I get the first yellow ball, right? I can get a yellow ball, again I can get a yellow ball, again I can get a yellow ball. Like, I there are 4 balls. Try to understand this. So there are 4 possible outcome. Either I get the first yellow ball, or I get the second yellow ball, I get the third yellow ball, I get the fourth yellow ball. Isn't it?
Yes, ma'am.
So there are 4 possibilities. Like, total possible outcomes are 4. But I want a red ball. So my favorable outcome is 0. So the answer will be 0. So in this case, the probability is 0. And yeah, so in some cases it can be equal to 1. Maximum, for example, I have only one yellow ball, right? Only one yellow ball is there in the bag. Now what is the probability of getting a yellow ball?
1.
Obviously my favorable outcome is occurring 1 time, and there are total possible outcome is also 1, so the probability is 1. So this is like example where you get 1 as the answer. So otherwise it always falls between 0 and 1. Second, which of the following experiments have equally likely outcome? Explain. First, the same example which I gave you, a driver attempts to start a car, the car starts or does not start. Okay, so this is not equally likely. What is the reason you will write?
It is dependent on the condition of the car.
Exactly. It can be old car, it can be a new car, or it can be a defective car which is already defective. So there are greater chances that it will not start. Okay. Second, a player attempts to shoot a basketball. He or she shoots or misses the shot. What do you think about this one?
Not equally
Not
likely.
equally likely.
Why?
Ma'am, because it depends upon the player. Like, if the player is professional, then
Exactly.
it
If
is
it's if he or she is a good basketball player, right? A trained basketball player, there are greater chances that he or she will not miss the shot, right?
Yes, ma'am.
So there is again a dependency here. So it is again not equally likely. Second, a trial is made to answer a true false question. For example, I'm asking you true false question. The answer is right or wrong. What about this? Is it equally likely?
Equally likely.
Yes, it is equally likely. There's no dependence here, right? Either it is right or either it is wrong. These are the two only possible outcomes. Either the answer is right or it is wrong. Fourth, a baby is born. It is a boy or a girl.
Equally likely.
Yeah. I think the question should not be here because there's a third gender as well. But anyway, we consider it to be equally likely. Should I rub it?
Okay, ma'am.
Okay. Next. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? So,
Ma'am, because it is equally likely.
yeah, so because the outcomes are equally likely, right?
Yes, ma'am.
That is why. So that means we can say the outcome is unpredictable here, right? There's no hint, there's no indication of any kind. So either we get a head or a tail. There are equal chances. Fourth, which of the following cannot be the probability of an event? Cannot be, okay? So 2 by 3. What about this one? See
It
this?
can be.
Yes, it can be. Why?
Ma'am, it can be reduced to decimal form and it's less than 1.
Yeah, as you can see, numerator is smaller. Like without reducing also, you can see the numerator is smaller. So it is less than 1, right? So it is 2 by 3 actually falls between 1. And because it's a positive number, it's greater than 0. So it lies between 0 and 1. So it can be a possible probability. Second, see, this cannot be. This is the answer because probability cannot be negative. It can be 0, but it cannot be negative. Okay, 15%. Again, 15%, you change this in fraction, so it is 15 by 100, right? Which can be reduced to 3 by 20. So 3 by 20, as you can see, numerator is smaller, so obviously it's less than 1, right? And it's a positive number, it's greater than 0. So it can be. Again, if you look at 0.7, obviously it's less than 1 and greater than 0. So this can also be a probability. Now, fifth one, if P of E is this much, what is the probability of not E? So it's simple. We know that P of any event plus P of not that event, the answer should be 1. The sum should be 1.
From 0.95.
Exactly. So it will be like P of not E will be 1 minus P of E. So it will be 0.95. Now, sixth question. A bag contains lemon flavored candies only, right? Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavor candy?
0.
0. So favorable outcome are actually 0. So it will be 0. And what is the probability that she gets a lemon flavored candy?
1.
Yes. Because favorable outcome is actually a lemon flavored candy, right?
Yes, ma'am.
Or you write like this, no? P of orange candy is equal to 0, right? And P of a lemon candy is 1. See, why 1? If I want to see from the formula, right? Formula is this, that number of favorable outcome upon number of possible outcome. Clear? This I told you the formula, right?
Yes, ma'am.
Okay. Now here it is not given like exactly how many candies are there. So let us assume there are 5 candies. Okay. So the possible outcome, either I get a first candy, I get a second candy, I get a third candy, fourth one or fifth one. So possible outcomes are 5, right? And all these outcomes are my favorable outcome because I want a lemon flavored candy, right? Either it is my first candy or it is my second candy, but although because it's a lemon flavored candy, so all these events are my favorable events, okay, favorable outcomes. So favorable outcomes are also 5 in this case, so that is why the answer is 1. Clear, Amna? Okay. Now 7th. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is this. Okay, what is the probability that they have the same birthday? So you have 3 students, right? Now you are picking any 2. So there can be 2 possibilities. Either they have the same birthday or they do not have the same birthday. Clear? So you use the same thing here, that P of an event plus P of not E is equal to 1. That you know, right? E you can mention like if E is an event, right? Now what is E? So you have to mention. So if E is an event, so P of event plus P of not event is equal to 1. So means probability of having same birthday plus probability of not having same birthday should be equal to 1. So I think you can find it now.
0.008.
Yes. So not having is already given. The answer is 0.008. I think 0.08, right? No, 3 digits are given. Okay, 008. Understood, Hamna? Now, 8th question. A bag contains 3 red balls and 5 black balls. So number of red balls is equal to 3. Number of black balls is equal to 5. A ball is drawn at random from the bag. Now please understand this term, drawn at random, right? Many times it will come in the question. So drawn at random means the same thing, that picking out one ball from the bag is not at all affecting the chance of picking out another ball from the bag. Clear?
Yes, ma'am.
Okay. That means if I pick out first ball, still the second ball is having the same chance of like being chosen from the bag, right? So every ball in the bag is having an equal chance of getting selected. Such event is called a random event. Fine, Amna? Or we call it like random selection. That selecting one outcome is not affecting the chance of being selected. I mean the chance of selecting the second outcome. Such events are called random events or random selection. I hope it's clear.
Yes, ma'am.
Every event is having equal chance of being selected. You can write it down somewhere. This is called random selection, that every event is having equal chance of being selected. Now, a ball is drawn at random from the bag. What is the probability that the ball drawn is red? Okay. Come back to the formula. Probability of red ball. So, number of favorable outcomes upon number of all possible outcomes. Right? So there are total how many balls in the bag? Total balls are 8, right? So what are the all possible outcomes? See, you are picking out a ball. These can be the outcome. Either it is the red ball, like the first red ball. It can be again second. It can be your second red ball. It can be your third red ball. It can be your first, you can say, black ball. It can be your second black ball, third black ball, fourth black ball, or fifth black ball. They're all identical, but you don't see, we don't know which one is first, but let us assume there are numbers written on in first, second, third, fourth, fifth, right? I mean, it should not be written, first of all, otherwise the event is not random, getting it?
Yes, ma'am.
Yeah, because it will affect the chance of being selected. But just imagine in your mind that this one is my first ball, this one is my second ball. So these are the possible outcomes. When you pick out a ball, it can be the third black ball, right? It can be the fourth black ball. So total 8 possible outcomes can be there. Understood? Now I want red balls. So there
3
are,
by 8.
yeah, answer is 3 by 8, but I'm just explaining why, right? The favorable outcome are 3. Now why there are 3? Because all these 3 outcomes are my favorable. It can be my first red ball, it could be second one, it could be third one. But although because there are all red balls and I want a red ball, so all these 3 outcomes are my favorable outcomes. Understood?
Yes, ma'am.
Okay, so my favorable outcome are 3. Total possible outcomes are actually, total number of balls. So 3 by 8 is the answer. Okay, now what is the probability of not red? So we know that probability of not red will be equal to 1 minus probability of red. Clear? I mean, you can write it down that P of E plus P of not E is equal to 1. This we know, right? So if we use this, so we can find the probability of not red, which is 1 minus 3 by 8. So take LCM, it will be 8 minus 3, that is 5 by 8. So I think these terms are clear in your mind, like what is a random selection, what is an event, right?
Yes, ma'am.
Okay.
Yes, ma'am.
Question number 10th. A piggy bag contains 150 paisa coins and this. So you note it down. Number of 50 paisa coins. How much? 100. Then number of rupee 1 coin. 50. 20, right? And number of rupee 5 coin is 10. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paisa coin, right? So total coins are how much in the bag? I think 180, right? 50 plus 70, 80 and 100, 180. So these are the total number of coins. Okay. So he is saying that events are equally likely in this case. Okay. There are equal chances of getting every kind of coin here. So what is the probability that the coin will be a 50 paisa coin, right? So probability of 50 paisa coin. Now my favorable outcomes are how much?
100.
100. Please write the formula, okay? I'm not writing it again, but you have to write in every question. So favorable outcomes are 100 and total possible outcomes are 180. So just to bring it to simplest form, the 10 cancels out, 10 by 18, which is equal to 5 by 9. Okay, now will not be a rupee 5 coin. So first of all, you find probability of rupee 5 coin and then subtract it from 1, right? So 5 coin, how many coins? 10. So my
10.
favorable outcomes are 10, total are 180. So 0, 0 cancels out, it is 1 by 18. So P of not rupee 5 coin will be 1 minus P of rupee 5 coin. So it will be 1 minus 1 by 18, which is 18 minus 117 divided by 18. Written? Hamna.
Yes, ma'am.
Okay, Harsha done?
Yes, ma'am.
Okay, next, 11th question. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random, right? So at random means chance of picking one fish is not affecting the chance of picking the second fish. So the shopkeeper takes out one fish at random from a tank containing 5 male fish and 8 female fish. So write down number of male fish is 5 and number of female fish is 8. So total number of fish are how many?
13.
Total number of fishes is equal to 13. Okay. What is the probability that the fish taken out is a male fish? So probability of male fish. So my favorable outcome are 5. It can be the first male fish, second, third, fourth. All 5 are my favorable outcomes. And total possible outcomes are 13. That's the probability. Better you write probability of a male fish. No, one male fish you're finding out. Okay, so you have written, I think. Now, question number 12, if you see, a game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers. So there's a figure, right? So either it stops at 1, it stops at 2, 3, 4, 5, 6, like this. And these are equally likely outcomes. So it is already given, they are equally likely. What is the probability that it will point at 8, right? So how many total number of outcomes are there? So either,
8.
yeah, so either the outcome is 1 or it can be 2, 3, 4, 5, 6, 7, 8. It can stop at any of the number. So total number of outcomes are 8 in this case. So what is the probability that it will point at 8, right? So my favorable outcome is this one. And every outcome is equally likely. My favorable is 8. So there's only one 8 here, right? So
Yes,
my favorable outcome is only 1. And total outcomes can be 8. So this is the answer, 1 by 8. Next, it is an odd number, right? So what are the favorable outcomes here?
Four.
Yeah, so what can be favorable outcomes? First of all, odd number mean it can be 1, right? Or it can be getting a 3, can be getting a 5, or it can be getting a 7. So number of favorable outcomes are 4, right? So these are actually the favorable outcomes, and there are how many? 1, 2, 3, 4. So total 4 outcomes are there, which will give you odd number. So the probability is number of favorable outcome divided by total number of outcomes, 4 by 8, which is actually 1 by 2. Right? Okay. Next, a number greater than 2, right? So what are the favorable outcomes? A number greater than 2. So it can be 3, it can be 4, it can be 5, 6, 7, 8, right? So number of favorable outcomes are how many? 1, 2, 3, 4, 5, 6. There can be 6 favorable outcome in this case. Understood? So probability is number of favorable outcome divided by total number of outcome, which are 8. So it can be reduced to 3 by 4. Hum now fine, Harsha?
Yes, ma'am.
Okay. A number less than 9. Now all the numbers are less than 9, right?
Yes, ma'am.
And so they all are now favorable outcomes. So there are total 8 number, totals are also 8. So probability is 1. So you can see probability is 1 here, right? Because obviously the number is going to be, all the time the number will be less than 9, right? So there are 100% chances that the number will be less than 9. Probability is maximum probability 1. Okay, next question. A die is thrown once. Okay, find the probability of getting a prime number. Yeah, 13th question. So prime numbers on the die. How many prime numbers?
3, ma'am.
Okay, now what are they? Either 1, 3, and 5. So these are the prime
Ma'am,
numbers.
2.
Sorry.
Ma'am, 2, 3, and 5, right?
Oh, prime number. I'm writing odd. I'm sorry. Yeah, okay, sorry. Prime numbers. Okay, so 2, 3, and 5. Yeah, good. So all these are my favorable outcomes. So there are 3 favorable outcomes. Understood, Hamna? So the probability of a prime number is equal to my favorable outcome are 3, total outcomes are 6, right? So when you throw a die, either you get 1, you get 2, 3, 4, 5, 6. So there are 6 possible outcomes. So this is 1 by 2 is the answer. Okay, next, a number lying between 2 and 6. So first of all, you mention those numbers. Numbers lying between 2 and 6. So what are the numbers? So you don't have to take 2 now, right? So numbers are 3, 4, and 5. That's it. Right? So my favorable outcomes are now 3. Okay? It can be any of the number. All are my favorable outcomes. So the probability of, what will you write here? Number, right? Number lying between 2 and 6, like right, like this. So 3 divided by 6, again 1 by 2. Now third, odd number. So you first of all write odd numbers on the die.